Hi guys, welcome to the channel. Today we're going to look at geometric growth and decay and using the recurrence relation to calculate the outcome of geometric growth and decay. So in this question we're told that a compound interest model on an investment of $2,000 paying at a rate of 7.5%, and we're told that V0, so the amount invested, is 2,000 and the recurrence relation is Vn plus 1 is equal to 1.075 times Vn. Okay, so first up, use a recurrence relation to find the value of the investment after 1, 2 and 3 years. Now we can't find 3 using this recurrence relation until we've found 1 and 2. All right, so that's the important part. So first what we'll do is set that up. So Vn plus 1. This is actually going to be V0. I'm going to change that. So we're going to find V1. So that's V0 plus 1. You'll see why that looks like that in a moment. And that's equal to 1.075 times 2,000. Okay, because that Vn there and Vn there are the same. This one here was V0 at the moment, because V0 plus 1 is V1. Okay, so we do that. We grab our calculator, 1.075 times 2,000, and we get a value of 2,150. And that is V1. Okay, now we've got that, we can find V2. So V2 is V1 plus one more iteration. So 1.075 times, remember that this one was 2,000 because that was V0's value. This one will be 2,150 because we're using V1. So just kick it up a notch. 2,150. Multiply that by 1.075. And we get $2,311.25. Next one is going to be V2. So this here is V2. 1 plus 1 still equals 2. So V2 plus 1 is equal to 1.075 again times the value of our last recurrence relation, so V2, 2311.25. Now, if you keep these in your calculator, you can just keep hitting times 1.075 multiplied by the answer, which is what I'm doing. So times that by 1.075, and that now equals 2484.59375. Okay, now we have to remember that this is, so that's V3. This is a financial value, so we go to 2 decimal places. So we have 2484.59. Okay, so $2,484.59. Go for that one. So part B asks us to determine when the value of the investment will first exceed $2,500. So to do this, we take our recurrence relation and keep repeating it until we get a value that's greater than $2,500. Okay, so here, and this you can do in the calculator just by, if you punch in, so the easiest way to do it is to put in, where am I? $2,000. And if you've got a Casio or at Texas, and then hit, generally you'll have an execute button, execute, hit that, then multiply, hit multiply by 1.075, and then just repeat that time and time again. So the first time you do that should follow our recurrence relation we've already done. Okay, so first time you get 2,150. Then we hit XE again. Okay, you get 2311.25. Hit it again. Get our last one there, 2484.59. So it hasn't quite reached our $2,500. So once more, and we get 2670.94. Okay, so we've done that. We've applied that recurrence relation once, twice, 3 times, 4 times. So it'll be after 4 years that is going to reach, the investment will be over $2,500. Okay. Now our last piece is, it asks us to, part C, it asks us to, I'll change the color a bit. Okay, so this last part of the question asks us to write down a recurrence relation if $1,500 was invested rather than the $2,000, and the interest rate's been changed to 6% per annum. So part C. So start off, we know what we're starting with, so V0. Nice, forgot my V's straight. V0 is equal to $1,500, comma, Vn plus 1 equals, so we need here our R value. So R is equal to 1 plus 6, that little r, over 100. Okay, it's important to note that the 1 plus is showing an increase. So whenever we multiply anything by 1, it's going to keep that original value, and then the 6 over 100 is going to add the 6% to it. Without that 1 plus, we'd actually end up with values that are less, which for an investment is not ideal. So 1.06 times, let's do a times Vn, and that's it. Okay, important thing to note is that that is not 1,500, because that changes every time that we add an iteration to it. So V0, that's 1,500. V1, that's whatever 1,500 times 1.06 is. All right, so that's the last part of our question there. Hope you enjoyed it, guys. Like, subscribe, thumbs up, all the above. Cheers, gang.